In this lesson 2.4.b, we'll be solving absolute value functions. Our objective is to solve absolute value functions algebraically and to understand visually that there are two solutions to every problem. If you can remember that, then you'll remember how to solve absolute value functions. So let's go ahead and look at some visual illustrations of what I'm talking about. So say you were given the problem, solve absolute value at x equals 3. So right now in your head, you probably have already solved this. You can think, well, x could be positive 3 or x could be negative 3. So here's an illustration down here of what I'm talking about. And we'll go ahead and highlight. So you could have a positive 3 or you could have a negative 3. And either one of those answers would give you a positive 3, because remember that absolute value of something ends up being a positive, just like distance. So x must be 3 or negative 3. Let's look at how this is on a graph. If I go to positive 3, my y value is positive 3. And let's go ahead and put some points on here. So this first point, the coordinates are 3, 3. And remember that in this equation, absolute value x equals 3. 3 is our y value. Okay, so that's our y value. So when x is positive 3, you can agree that y is also positive 3. But over here, when x is negative 3, y is still positive 3, right? We go over negative 3 and up positive 3. So therefore, there are always going to be two solutions. Okay, but how are you supposed to solve this if you don't already know what the answer is? Something like this is very simple. It's easy to look at and figure out what the answer is. Well, the solution is just to break the absolute value equation into two different cases. So we have to use the positive and negative property of this absolute value equation, knowing that we can use a negative or we can use a positive and still get to the same answer. All right, let's look at an example of how that works. Okay, let's say we were given this equation, solve absolute value x plus 2 equals 7. Well, in order to solve it, we need to clear the absolute value bars. So I must split the equation into two possible cases, one for each sign. There are multiple ways to do this, but I find that the easiest way is to write the left side twice, the one that's in the absolute values. So I will write x plus 2, and then I will write x plus 2. So what I'm going to split up is the 7. I'm going to do one equation where I leave it as positive 7, and I'm going to do a second equation where I change it to its negative alternative, the negative 7. So I'm going to take the opposite sign. Okay, and then the easy way to do this is to go ahead and draw a line that splits these into two different problems so you don't forget. Okay, and I do this on every single absolute value equation. It helps me remember how to solve them. Well, once you get something like this, that's pretty easy to solve. We just subtract 2 from each side, and we will have our answer. In this case, x is equal to 5. And we would do the same thing here. We would need to subtract 2. Only now, on the right side, we have a negative 7 minus 2, which is the same thing as negative 7 plus a negative 2. So we would get negative 9. Okay, we have two answers. We have x equals 5 and x equals negative 9. And that's what we should be looking for anytime somebody asks us to solve an absolute value equation. We should be looking for two answers because of our graph down here. So let's look at our graph. This says to confirm our answers graphically, we would want to look for the intersections of two equations. One equation is y equals absolute value x plus 2, which is our left side, and the second equation is y equals 7, which is our right side. So essentially what we have graphed are these two equations here. Okay, we'll highlight those. We graphed this one, y equals absolute value x plus 2, and that would be the v, right? Absolute value equations make a v. This plus 2 means we shifted left 2, So here's our vertex for that. And let's write in our vertex. Our vertex is -2, 0. Okay, that's our transformation. And we also graphed this equation, y equals 7. Okay, and our y equals 7 is our line right up here. And the way we graph that, if you remember, is we go to where y equals 7, and that's right here. You can count up 1, 2, 3, 4, 5, 6, 7, and then we drew a line through it. So our two intersection points are here and here. Let's look at the x value for those intersection points. This x value should be 5. 1, 2, 3, 4, 5, and it is. Okay, so the coordinate points for here are we went over 5 and then obviously up 7. The x value for this point over here should be -9, and if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, it is in fact -9, and we went up 7. So here's our two x values that we solved algebraically, and we verified that graphically. -9 and 5 are the solutions. That is what x can be and still give us a value of 7. All right, let's solve some more algebraically. Okay, so our first one, solve x minus 4, absolute value x minus 4 equals 2. Let's go ahead and do that. Well, we know we need to write it as two separate equations. Anytime you see the absolute value bars, your brain should automatically think I need to write it twice. So our first one is going to be x minus 4 equals 2. Our second one will be x minus 4 equals -2. So I've turned my 2, I've left it the same, and I've changed the sign and turned it into a -2. Well, on this first one, we would just add 4 to both sides, and we would get a solution of x equals 6. Second one, we would still add 4 to both sides, and we would get a solution of x equals -2 plus 4 is 2. Our solutions are x equals 6 and x equals 2. Okay. In our second example, we have a 3 in front of the absolute value. So one thing that we need to do is we always need to isolate the absolute value before we break it into two pieces. So that's an important note. Let's make a note up here. We'll star it. So we need to remember to isolate the absolute value prior to breaking into two equations. So I went ahead and wrote it up there. Isolate the absolute value prior to breaking into two equations. Well, in number 2, we haven't isolated it yet, so we need to move the 3 to the other side. Think of the absolute value marks as parentheses. Right now we are multiplying 3 times the absolute value of x. So to move it to the other side, we would need to divide by 3. Divide both sides by 3, and that will give us our new equation, which is absolute value of x is equal to 5. And in this case, we don't really need to write two equations because you can look at this and solve and know that x, one of our solutions, x will be 5. 5, absolute value of 5 equals 5. And in our other solution, absolute value of -5 will also give us 5. Okay. Third one, our absolute value is isolated on this one, so we can go ahead and solve this, break it into two equations. Our first equation will be 4x plus 6 equals x plus 8. Okay, now here's where it's a little bit tricky. We have to make the right side negative. So we have 4x plus 6 equals, we need to put a negative in the front because we need to apply the negative to the entire equation. Okay, so that means we need to distribute a -1, it's understood that there's a 1 in there, to the entire equation. Okay, and we can even draw in a 1 if that helps. Okay, so there's a -1 in front. That's how we make the right side negative, because we have more than one term over here. All right, let's go back to the first one. So in this case, we need to combine our like terms. Well, we need to put the x's together and we need to put the constant terms together. So first I'm going to subtract x and move it to the other side. And I will be left with 3x plus 6 equals 8. Okay, I'm going to go ahead and move the 6 to combine it with the 8, so I'm going to move it to the other side. And I will be left with 3x equals 2. Finally, last step, I'll move the 3 over by dividing, and I will be left with x equals 2 over 3, or 2/3. Okay, back to the right side. So what I need to do is distribute the -1 into the parentheses. So on my left side, I have 4x plus 6 equals -1 times x is -x. Okay. -1 times 8 is -8. Notice now the parentheses are gone. I've distributed the negative into the parentheses by taking that -1 and multiplying it by each term. Now I'm going to do what I did on my left, and I'm going to combine my like terms. So I'm going to do the opposite. I have a -x, so I will add x to both sides. 4x plus x, that's like a 1x, so I have 5x plus 6, and on the right side now I just have a -8. Okay, now I'm going to move the 6 over by doing the opposite, by subtracting. So I will be left with 5x equals -14, and then I need to divide both sides by 5, and my solution is x equals -14 over 5. One thing that I want to show you, anytime you have an x on the right side, you should always check your solution to make sure you don't have any extraneous solutions. It is possible to set up an equation in which there are no solutions or one solution. In fact, if you can picture, and let me draw an image down here, what if you had a graph that looked like this, and here's our line. Let's say our absolute value equation was somewhere up here. So let's say that was our left side of the equation. That was y equals absolute value of, say, x minus 1. And then let's just say the right side was -4. Well, that would be graphed down here, y equals -4. So will these two ever intersect? And the answer would be no, these would never intersect. So if I had given you an equation like that, you would find that there was no solution. Okay, and sometimes there is only one solution and one of the solutions doesn't work. Well, an easy way to check this is to graph it. So what I'm going to do is graph y equals 4x plus 6 as an absolute value function, so you'll see a v, and then I'm going to graph y equals x plus 8. That's a linear function, so you should see a sloped line. And I'm going to look at where they intersect, and what I'm going to look for is that there are two intersections, and that one of them is going to be this x equals 2/3, so I should see an intersection where x equals 2/3, and then I should also see an intersection here where x equals -14 over 5. And -14 over 5 is approximately equal to 5 goes into 14 two times with about 4/5 left over. So I should go to the left about 3. All right, so I've done my graphs, my two graphs, and here's what you see. So I'm just looking for my intersections. I have one here and I have one here. And this is -2.8 for x, and this one is approximately 2/3. 0.667 is approximately 2/3. So both of those answers are viable. They are both solutions. Okay, let's move on to our final example. Okay, in our first example, we'll notice right away that our absolute value equation is not isolated, so we need to isolate it. In order to move the -1/3 to the other side, we can do something where we multiply by the reciprocal. So what we can do is multiply the left side by 3 over 1. If we flip the fraction, we get the reciprocal, which means then we need to multiply the right side by 3 over 1. Okay. -3 over 1 times -1/3 turns into +1. So what we do is we now can just write x plus 8 because that is gone. We don't need to write the 1. Then on the right side, 6 times 3 is 18, and 1 times there's understood to be a 1 here under the 6. 1 times 1 is 1, so 6 times 3 is 18. Okay, now we can write our two equations because we have isolated our absolute value. So we have our first equation, leaving the sign as it is, and then we have our second equation where we are going to flip the sign. Solving for this, we subtract 8 from both sides, and we end up with 8. Subtract from 18 gives us 10. And on the second one, we do the same thing, subtract 8 from both sides. And we end up with negative 18 plus a negative is going to give us a negative 24. Our two answers will then be 10 and negative 24. If we plug those in, both of those answers will give us positive 6. All right, let's quickly go over this last example. You can see that we do not need to isolate the absolute value. It is already isolated. But we do have an x on both sides, so we will need to check to make sure that our solutions are viable, that they are in fact solutions. So let's go ahead and solve. Okay, let's write our left side equation as it is without changing the signs. So we have 2x equals 3 parentheses x plus 4. And then our right side, we will need to change our sign from a positive to a negative. So let's go ahead and put a negative in front of our 3. And then let's solve. So we have 2x on the left equals, distribute the 3, 3x plus 12. Let's go ahead and subtract 2x from both sides so we avoid having to work with negatives. On the left side now we have 0. 3 minus 2 is just 1, or 1x, plus 12. I'll subtract 12 to move it to the other side. And my final answer is negative 12 equals x. So one of my solutions I'm getting is negative 12. Now let's look at the right side. We have 2x equals negative 3x minus 12. This time I will add 3x to both sides, since my 3x is negative. 2 plus 3 is 5x, and I end up with negative 12. Okay, and then I will divide both sides by 5. And I get an answer of approximately 5 goes into 12 2 times, with 2/5 left over, and 2/5 is 0.4. Okay, so I can write it like that, or I can write it as negative 2 and 2/5. So what I want to do now is plug in my solutions and make sure that they actually work. So let's try that. The negative 12 will be easy to plug in. I would do 2 times negative 12 in my absolute value is equal to 3 times negative 12 plus 4. Okay, 2 times negative 12 will give us the absolute value of negative 24. And then I have 3 times negative 12 plus 4 would give me negative 8. I have absolute value of negative 24 on the left is equal to negative 24 on the right. Well, absolute value of negative 24 is actually positive 24, and that does not, in fact, equal negative 24. So we can say that this solution here is going to be extraneous. That is, in fact, not a solution. And we can graph that, and we can see what that's like. And let's go ahead and graph it rather than plug in negative 2.4, because that would be a lot more work dealing with the decimal or the fraction. So let's go over to our calculator, and I wrote it up here, desmos.com, if you'd like to graph these yourself and verify your answers. So what I'm going to graph, my first equation will be y equals absolute value of 2x. So let's write that up here. So this will be my first one. This will be y1 will equal this one. And then my y2, I'll just type it in exactly as I see it, will equal the 3 parentheses x plus 4. So when we head over, this is what my graph looks like, and let me show you the equations that I plugged. And here they are. So here's my y1, absolute value of 2x. My y2 is 3 times x plus 4. Here is the red one, the absolute value makes a V. The blue one is a linear equation, and you'll notice it is only intersecting in one place, at the negative 2.4. Our other answer that we got, we can go back and look, was a negative 12. And when I look here, negative 12 is over here. This blue line will definitely not intersect this anywhere negative 12. So you can see why that is extraneous. And we can also see and confirm that the negative 2.4 is in fact a solution. So a couple things to keep in mind before we end. You will always need to break this into two equations when you see absolute value. One equation, you will just remove the absolute value bars and write the equation as it is. The second equation, you will also remove the absolute value bars, but you will make the right side negative. So you will, or positive, you'll actually do the opposite. Second thing you need to remember is that anytime you have numbers outside the absolute value, you will need to, and we'll go back to that slide, isolate the absolute value prior to breaking it into two equations, like we did in this example, or at the very end, like we did in this first example here. So remember to do that. The third thing you need to remember to do is if you have an x on the right side, you always need to check both your solutions by either one, plugging them back into the equation, or two, making a graph and graphing the left side as an equation and graphing the right side as an equation. And you can go to desmos.com. I showed you how to do that. And you can verify that they do intersect in two places and that at both these x values. Okay, and let me just have a slide here for you in case you want to take notes, and you can write down the summary. And there is your summary. So if you need to, go ahead and pause the video and you can write down what I just said. And that concludes our lesson for today.